This is the first video for 3-3. You're going to take the handout and do the warm-up with a table partner or someone else who you work well with, and only come back to the video once you've decided on some good ideas and written them down for the items on your sheet. If you're back, that means you're ready to check. So we'll leave this moved up and down for some ideas. You want to see if you have the right ideas. Not exactly this verbiage, not exactly this wording, but you have some of the right ideas about the differences. And can you add a couple things that you can use as notes later to study from or think about that helps you define the difference between these two or make them separate somehow? Show how they have some things the same, but then there's a difference or something different about them to help your memory with those items. Then when you're done looking at this, unfreeze the video or unpause it and move on to the homework correction part. But do make good corrections here and pause the video. If you've moved on, you're checking homework. So in number 3, they'd asked you to put your segment so close to the edge of the paper that you could not swing arcs on both sides to make a perpendicular bisector. And in doing that, they're really asking you to come up with a way that shows you understand that you're finding two equidistant points. You don't need to worry that you can't find them on opposite sides of the segment. If I can find one equidistant point here and then another equidistant point on the same side, I could still carry out the idea of the perpendicular bisector construction. So from both ends, I could set my compass to one amount that's more than half and do a nice arc swing, and I'm faking, which you guys know is a bad idea. Okay, that would be equidistant from both my endpoints. Then set my compass to a different length that's more than half. And again, do the same thing. Do another compass swing to get a second equidistant point on the same side. Connecting through those and to the segment is going to create that perpendicular bisector that you'd be seeking. Sometimes that's very helpful to keep the arcs out of the way of other things, to be able to put two arcs on the same side as they show in number 3. Number 5, you have two choices. They went ahead and first got the sum of the two lengths, so they made a segment that they had length AB marked off from M, and then they had length CD marked after that, so they made a segment that was the total lengths. After that, then they bisected it so that only this part on each side of the perpendicular bisector is that average distance or average length they were seeking. You could carry this out another way by first calculating, think distributive property. That would be equal to if I first found half the length of AB by construction and found half the length of CD by construction separately, and then made a new working line and marked off half of each amount so that they'd add up to that distance that we were looking for as well. And finally on number 12, where to put the post offices on these two, on this island. So they had 2 stations, and they were trying to figure out where you'd be equidistant. So therefore, if you're equidistant, you could go to either post office. But any point on the perpendicular bisector between those two would be those equidistant points. Anywhere on that perpendicular bisector, I'd be equidistant from both post offices. Anywhere on this side, I'd be closer to the one on that side, meaning that end point. And anywhere on this side of the perpendicular bisector, I'd be closer to the one at Nest Station. So that would tell me where that would fall, so I could tell who could go to which one more quickly. When you are done checking homework and making corrections, then make sure it gets into the turn-in folder before you start the next lesson video.